What would happen if we were to detonate a very powerful nuclear weapon on the moon? Would the explosion knock its orbit toward Earth, causing tidal waves and destruction? Could the moon be destroyed, showering the Earth in a rain of meteoric debris? During the Cold War, the moon was a major target for space exploration and military bases. So, the US Air Force commissioned a serious study into the effects of a nuclear detonation on the moon's surface. Let's conduct a scientific experiment with an imaginary 100 megaton thermonuclear warhead, about twice as powerful as the most powerful bomb ever detonated. We'll also place observers around the moon. Let's push the button and slow down time. For the first few milliseconds, nothing much happens outside the weapon. Inside, high explosives send a shockwave to a radioactive metal core, compressing it until it reaches criticality and starts a nuclear fission chain reaction. The 100 million degree plasma created in this first stage sets off the second stage, with atomic nuclei fusing like in the core of a star. Very briefly, the weapon contains one of the hottest places in the universe. Barely 10 milliseconds later, the bomb dissolves, and a flaming star of nuclear energy is born. Everything that happens now is very different from Earth due to one major difference. There's no atmosphere. As the fireball shines, it releases a flash of X-rays and thermal photons, a wave of heat rushing outwards. On Earth, this heat would char and burn everything within a 50-kilometer radius. But on the moon, without an atmosphere, there's no burning at all. Also, there are no things to burn. The lunar surface is made of silicate rock and metals, mixed with tiny traces of water. When heated by the explosion, X-rays from the fireball vaporize a thin cloud of rock from the lunar surface, while dust inside the fireball melts into glass. Any astronauts within 50 kilometers can expect to be exposed to lethal radiation. One of the biggest differences between explosions on Earth and in space is that on Earth, the atmosphere fights back against the plasma bubble. Its expansion is violently stopped by atmospheric pressure. This creates the shockwave, the most destructive part of a nuclear explosion on Earth. But on the moon, there's no atmosphere, and therefore no shockwave. The fireball expands silently as nothing impedes it. This would be amazing to observe from a distance. Unfortunately, there's no safe viewing distance for a nuclear explosion on the moon. Without an atmosphere to weaken the ionizing radiation, anyone close enough to get a good look will be exposed to fatal radiation. The explosion also transfers about 1/10 of its energy into seismic waves, causing a moonquake. The moon is much smaller than Earth, so astronauts will feel violent shaking no matter where they are standing. The shaking could damage or level any structures on the moon. Where the bomb explodes, the ground splatters like water when a rock hits a pond. The explosion may excavate up to 100 million cubic meters of dust and rock, forming a crater about 1 kilometer wide. Debris is shot into the sky in every direction, with no atmosphere to slow it down. Much of the debris will escape the moon's gravity and may rain down on Earth. Any satellites or space stations in its path will be at risk. Micrometeorites will punch through astronaut suits or equipment, no matter where they stand. Finally, the explosion ends. On Earth, a nuclear fireball rises and forms a mushroom cloud, but on the moon, there's no atmosphere, so there's no mushroom cloud. The plasma bubble cools and fades quickly. It might be visible from Earth as a brief flash. Tiny debris illuminated by the sun will give the aftermath an eerie beauty. As for the moon's orbit, it will remain unchanged. Moving the moon with a nuclear bomb is like trying to move a truck by blowing on it. The explosion only leaves a crater among millions. However, the surface of the moon will be contaminated with radioactive material. Without natural processes to wash it away, the contamination will last a long time, though the worst radiation will decay within a year. In conclusion, while the moon itself would barely notice a nuclear explosion, using the moon as a nuclear test ground would ruin it for future explorers or builders. Therefore, it is not advisable to use the moon for such purposes.